Good evening. President of the Academy, past presidents of the Academy, Vice President Arts, fellows, distinguished invited guests, family of the speaker, our students, press, ladies and gentlemen, all protocols observed. My job here is really quite simple, to introduce the speaker, but I'm also expected to just make a few remarks. I think the Academy, and indeed the whole nation, is quite clear that Galamsey is posing an existential threat. Very soon, the very air we breathe in will be poison. The water we're drinking, or what we're drinking already, is poison. And food that we'll be eating eventually will be poison. The long term is long-term diseases, kidney diseases, liver diseases, cancers. That is what is ahead of us if we don't take things serious. It's no more in the mining sector. It's no more a village, rural, urban divide. This is a national disaster. And I think we should all rise to make sure the right thing is being done. And I think our speaker today is Professor Ofori-Sarpong Akuffo. Is going to provide us data to show us the dire situation that we are in. But she proffers us some hope that if we do the needy, we can indeed salvage something out of this disaster. So we can't wait to hear what our speaker will be talking about: gold beneficiation in Ghana, promoting sustainable practices. You can't do away with that, but promoting sustainable practices. And now, let me give you the distinguished profile of our distinguished speaker. Our speaker is no other than Professor Mrs. Grace Ofori-Sarpong Akuffo, Fellow of Ghana Academy of Arts and Sciences. She is a professor of minerals engineering and currently the Dean of Planning and Quality Assurance Unit at the University of Mines and Technology, UMAT, Tarkwa, Ghana. Professor Ofori-Sarpong Akuffo holds a PhD in energy, mineral engineering from the Pennsylvania State University, USA, an MSc in environmental resources management, and BSc in metallurgical engineering, both from Kwame Nkrumah University of Science and Technology, Kumasi. Now, her previous positions held in UMAT include Dean of School of Graduate Studies, Acting Pro-Vice Chancellor, Dean of Faculty of Mineral Resources Technology, Vice Dean of Planning and Quality Assurance Unit, Head of Petroleum Engineering Department, Head of Environmental and Safety Engineering Department, and Coordinator of the university's examinations. She also serves as a member of several national boards and councils, including the governing boards of the Ghana Academy of Arts and Sciences, the Minerals Income Investments Fund, MIF, and Ghana Chamber of Mines, the Tertiary Education Fund, the International Advisory Board of African Center for Mineral Exploration and Development, ACMED, and the Amira Research Consortium. In addition, she's a fellow of the West African Institute of Mining, Metallurgy, and Petroleum. She is also a member of the Society of Mining, Metallurgy, and by now I know how to pronounce the word, metallurgy, and exploration engineers, and International Association of Engineers, Society of Petroleum Engineers, and Women in Mining in Ghana. Professor Ofori-Sarpong Akuffo is a fellow of the Ghana Academy of Arts and Sciences. I must also say there are members online waiting anxiously to hear from us. So audience, I give you your speaker and your speaker, Professor Grace Sarpong Akuffo. Thank you very much.
the chair of the 2024 annual lecture in sciences, Professor Emerita Professor Isabella Quakyi, the president of the academy, past presidents, vice presidents, the executive body of the academy, fellows, my distinguished sponsors, family, friends, and loved ones, our students gathered here, and all our audience viewing us on various platforms virtually. Good evening. I must say that it's a great honor to be given the opportunity to deliver the 2024 annual lecture in the sciences for the Ghana Academy of Arts and Sciences. For today's lecture, my topic is gold beneficiation in Ghana, promoting sustainable practices. It's very interesting that this topic came up at the early part of this year. In fact, little did I know that by the time I'm delivering my lecture, there will be all sorts of issues about mining, galamsey, environmental pollution, health issues, and all that. But I'll do my best to address it from my technical point of view. Let me try my pointer here. All right. No, can I remove it? Yes. Thank you very much. So, by the time we are done with this lecture, the expectation is that my audience would have or will become acquainted, because I cannot teach you everything about mining and metallurgy today, but at least you become acquainted with the general uses of mining and its products in our everyday life, technical beneficiation of gold from the large-scale sector and also from the artisanal and small-scale sector, the inherent effects of mining and mineral extraction on our environment, sustainable measures put forth by especially the large-scale miners to reduce the environmental impacts, the menace that is left behind by artisanal and small-scale, especially the illegal one called galamsey, and then some suggestions on the way forward to ensure sustainability. All right. So, the outline that is going to guide me to go through this lecture is what I have projected. We will look at mining and mineral beneficiation, products of mining and their uses, basic definitions used in mineral beneficiation. We'll look at gold, then Ghana's position in the global gold production. We will look at geological map where we find gold in Ghana, and then the process of gold beneficiation at the large-scale level and the small-scale level, challenges and interventions in artisanal and small-scale mining operations, and then we'll look at how we can promote sustainability in the way forward. Yes. So, when we talk about mining and minerals beneficiation, mineral beneficiation, the word beneficiation, is any process or all the processes put together to separate economically essential mineral from its ore. Economically essential mineral from its ore. And the ore is actually a rock mass. I'll show you a picture soon. So we have a rock mass and it contains minerals, and we want to take the mineral that we are interested in. Before we can get access to that rock mass, we need to take it out of where it belongs and bring it to where we can go through the processes. And the process of taking it out of the mass and moving it to another position is what we call mining. So mining is employed, we say, for any material that cannot be grown through agriculture or created artificially. We cannot grow it. These are the mineral resources that are endowed in the earth. We cannot grow them. And if we cannot create them artificially, then it is only by taking them out of the earth that we can have access to them. Some of the examples of these minerals are iron. So we say that Ghana, we have iron deposits. So if we need that iron from that deposit, then we need to take it out. We have bauxite, from which we can get aluminium. We have the pegmatite ores, where we can get our lithium from. We have crude oil, where we can get our petrol, diesel, and all those that we put in our cars. Then we have the gold ore, and I believe most of us are interested in having gold all around us. We have salt, so we have to mine salt to be able to get it to use in our homes and industrially. Sand for our buildings, stones, and limestone, just to mention a few. Okay, so the products of mining and their uses, I'll just mention a few. If we look at the health sector, for example, we see some people, they have an artificial tooth and it's made of gold. That gold came from the earth. Okay. We have magnesia. Sometimes when we have a stomach upset, we take this aludrox and all those. They contain minerals. We have a titanium alloy that is used as implants, and all these are coming from the earth. How about the construction? This building that we are living in, we are here, and the building was put up using stones, using sand. We see a lot of gadgets around. We see the chairs. You know, we can have some parts that are from the minerals that we extract from the earth. Okay. We want to drive on tarred roads. The bitumen or the coal tar also comes from the earth as a product from crude oil. And then definitely we have our gold and all that. One other interesting thing is the rare earth elements that we are talking about today because of the energy issues. Where are they coming from? They will also come from the earth. And then textiles, the materials that we put on, also coming from the earth. Okay, right. Yes. So if we look at this diagram, it's talking about the renewable energies, which is good because we want to go zero carbon. So we are looking at solar, we are looking at wind, we are looking at carbon capture, you know, nuclear energy, and all those, electric vehicles. But the electric vehicle is going to use electricity. But the structure itself is made out of iron. It is steel. It will have aluminum part, and it will have other minerals. And then, even where we are going zero carbon, we are talking about critical minerals that we will use. These critical minerals include, for example, cobalt. Where is it coming from? We will have to mine and get cobalt so that we will stop using carbon, so that we can use our electric vehicles. So these are just some of the examples. Let me move to the next slide. Right. So having set the platform this way, let's look at how we can get these minerals from the earth. Since some of them are essential and we must get them anyway, but how do we get them? All right. So let me give a brief definition for the sake of those who are not metallurgists or miners. When we talk about a mineral is a naturally occurring solid that has distinct chemical composition and structure. So if we mention gold, gold is a mineral. Manganese is a mineral. Iron is a mineral. So these are all minerals. Now when we talk about a rock, like what I have here, okay. This is a rock, right? A rock is an aggregate of millions of minerals. So several minerals coming together will form the rock. When a rock is referred to as a deposit, it means that it contains a particular mineral in substantial quantity. So if we talk about iron deposit, as we have in Ghana, upon Mansi and the rest, it means that it contains a substantial amount of iron that we can extract from the deposit. But the extraction should be economical. So if we check and we can extract the mineral from the rock economically, that is, make profit out of it after paying for all our expenses, then that rock mass is referred to as an ore, O-R-E, that is an ore. So if we take an ore, for example, we metallurgists will simply split it into two, even though it contains several minerals. The two will be the mineral of interest, the one that we are interested in, and all the other minerals put together, we call the unwanted minerals or the gang. So when we talk about gold ore, we are talking about gold as the mineral of interest, and all the other things we don't like as the unwanted minerals or the gang. This is gold. It looks so nice. Gold is special. I mean, it's special in every aspect. It's so beautiful. It's cherished by everyone. It is noble, and it is priced. It is very expensive. Everybody wants to have gold. You know, it creates some kind of power when we have the gold. So looking at Ghana, Ghana contributes about 90% of gold. Sorry, the gold in Ghana contributes about 95% to the mineral worth of the country. So even though Ghana has different minerals, but gold is the most prominent. I believe that is why we talk about gold a lot. You go to other countries, it may not be like that, because probably their prominent mineral will be iron or copper or zinc and the rest. But in Ghana, the most prominent is gold. And gold contributes a lot to the nation's economy through direct employment and indirect employment. And last year, 2 years ago, and last year, we talked about gold being at the top when we rank the gold-producing countries in Africa. Right. So, as of today, yes. If we look at the whole world and all the countries producing gold, we have Ghana being at the 11th position. And Ghana is respected by some other countries because of its wealth in gold. We have people rushing into Ghana because of the wealth that we have in gold. And this slide, the pointer is not working. Okay. We are looking at several mining companies in Ghana. All these are large-scale mining companies, and the contributions they are making in terms of gold production. Let me mention here that if you take these mining companies, indeed, about 70–80% of them are doing surface mining. Just a few of them are doing underground mining. Right. So we are looking now at the geological map of Ghana. why gold is so prominent, why everybody talks about gold. And if we look at, it's not showing very well, but you will see that there are some, okay. So if you follow, you move away from the water area and you go to that is southwest. You see those lines like this. They are called gold belts. So the gold belts actually move across the entire country. And that is why in Ghana, it is said that wherever you can dig deep enough, you are likely to find gold. But finding gold and then going after it and getting it will depend on the quantity of the gold in the ground. So if we want to follow the gold in the ground, then we have to go and dig. So the picture I'm showing here, which unfortunately is not showing very, very well, but it is showing a mining pit in a large scale. So this is a hard rock, and if they want to mine, they cut it. So for example, if we look at this room, you look at the upstairs here, that will be a floor where they are mining, and if they want to come down, they will have to step it and come down. So they step and go like that. They don't go, vertically like that. And that is the way the large-scale miners do it. Because if they go like that, it's going to collapse. They would have invested a whole lot of money into it. So they themselves wouldn't want to do that, to lose the money and also lose human beings. And then we are looking at the different kinds of rocks. So the rock I showed you, I still have it up there. That is the upper right. Yes. When you go down, you realize that it is broken down into pieces. So if we go and we have the rock mass and we want to get it, we will have to break it into pieces, and that is blasting. So blasting will be done to break it into pieces, and then it will be moved from where it was originally into the processing plant where the extraction will be done. However, we can also have gold ores where we don't have a consolidated material. So we have it free like sand, and the gold particles are naturally liberated in that. And those ones are called the placer ores. And those are the ones that the illegal galamsey people will go after, because it is easy to get the gold out of it. And this one can be found in river bodies, in which case we call it alluvial. So if it is found in river bodies, then they are chasing after it, because that one, when you take it, and you will see the gold particles within it. So it's easier for them once they are not ready to invest into the operation. Right. So the next slide, please. Yeah. Processes of gold beneficiation. Now this slide is going to help us to appreciate why we have all those problems around. When we talk about the gold, it is very, very, very low in concentration. So for example, we can talk about 2 grams per ton. And today, if a mine is written 2 grams per ton, it is not considered as low grade, because some of them are doing less than 1 gram per ton. What does that mean? If the gold is, let's say, a ball, we are chasing after 2 balls out of 1 million balls. That is the situation. 2 balls out of 1 million balls. So if it is 1 gram per ton, we are chasing after 1 out of 1 million. How do we get this 1 out of the 1 million? I mean, ball is like blown up so much. What we have, the gold particles are very, very tiny. And it is not one together, like the way I described the ball, but it is highly disseminated, which means it is spread through the entire 1 million parts, and we are looking for it within the 1 million parts. So if we are interested in, let's say, 20 grams, how many are we going to go after? And therefore, if a mining company sets up and it is chasing after the gold, then it has to, take a lot of material from the earth, take it through the process before they will be able to gather enough to pay for the expenses. And that is why it leaves us with a lot of problems. So it's like inevitable. Once we are taken, it's going to create environmental problems. Now, this 2 grams is what we are expecting, but the recovery it's usually less than 100%, which means that we are not even going to get it. If the ore is easy to treat, what happens is that we are able to recover about 95% of the total gold that is in the rock. And easy to treat, if it is hard rock, we have to grind it all the way to less than 1 millimeter before we can get this 95% recovery. So that is the challenge that we have when it comes to gold processing. Let's look at this flow sheet. Okay, yes. So this flow sheet gives us a platform for a large-scale gold mining processing. Okay, we look at it from the left. We have the stockpile. So the stockpile is the material that has been mined from the pit to the processing plant. And it has to go through crushing, where we will break down the particles because it is big. Then it goes through milling, and then we have to separate it, so we see a cyclone. Okay, so the blue thing over there, that is the mill. Okay, thank you. So that is the mill. Then it goes through the cyclone, where we are separating bigger particles from smaller particles. In fact, this is a typical processing plant for a large-scale gold mining. Then the lighter ones, that is the smaller, finer particles, will go through thickening because it contains a lot of water. And that will go to what we call CIL, that is carbon in leach. I'll talk about that. So we use oxygen and cyanide to get the gold from the solid state into the liquid state, dissolution. And then we add activated carbon to take the gold ions from solution. The bigger particles from milling will come out as the cyclone underflow. And that will contain some bigger particles of gold. And usually we want to take that out. We don't want to take it through the leaching because it will not be completely dissolved. So it goes through the gravity concentration, and I want you to take note of the gravity concentration because I'll talk about it when we enter into the small-scale arena. So the gravity concentration basically is using the principle of the difference in specific gravity of gold and the unwanted materials. And I've said that all the other minerals, we classify them as gang, unwanted materials. So gravity concentration will use the fact that gold is heavy and then get the gold out. Once we get the gold out, we take it through another form of dissolution. And here we are talking about intensive cyanidation. Because the particles are big, we need high concentration of the cyanide to be able to dissolve it. Then the tailings or gang from here will go back, get milled again, and it goes through the process. So after the intensive cyanidation, we have the gold concentrated in solution, and that will go through electrowinning. The one that we leached here, and we absorbed it onto carbon, will go through another dissolution stage, where we take the gold back into solution from the carbon. And that will also go through electrowinning. The gold ions will be caught by the cathode in the electrowinning cell. And that cathode, we will take it into the smelting room, smelt it before we get our gold bars. So indeed, the way I have spoken about it makes it very, very simple, but it is a very complex operation. So this is for the large-scale mining. So if you look at a structure like this, you will realize that to a large extent, everything is contained. Everything is contained. If they are leaching in the tanks and they take the gold out, whatever is left is going into a tailings dam, which is an embankment designed to receive the tailings and to contain it. And to actually treat it if it is not meeting the environmental standards. So that is the large-scale gold mining. Right. So the large-scale gold miners, they have to, in fact, a lot of regulations that they have to follow. Even the people that must work there is regulated. And if they don't have the right caliber of people, they have an issue with Minerals Commission. They have to do continuous exploration. They have to do proper mine planning of the site. They have to maintain the haul roads. They have to put in a well-designed processing plant fit for the purpose. What I have shown is the very easy-to-treat material, but we have some complex materials like sulfides, carbonaceous materials. If they have that, the processing plant is going to be more complex than the one that I showed. They must have well-engineered tailings impoundment, and they are supposed to send returns to EPA, to Minerals Commission, periodically. They must take samples and check and know the metals, if there's anything going out of their area into the environment. They must check, and then the regulators also go there from time to time to check. So that is the case of the large-scale mining company. Okay, this one is showing a tailings impoundment. This is a real picture taken from a mining site. So that is the way it is. Indeed, if a tailings impoundment gets full, a mining company, does not even allows that. Because if it gets full, it means that you have to shut the processes. Because the process is continuous. And the waste, huge amounts of waste coming out. So if you don't have a place to contain it, then you cannot even continue with the operation. So they are very, very serious about that. All right. Now I think I've talked a lot about large scale. I want to switch to small scale. So this diagram is showing us the Ghana map again. And it is showing us spots where we have small scale mining going on. Indeed, this diagram talks about gold, construction materials, diamond, and salt. But I guess our interest for today is gold. So the gold is the one with star. So all the stars here. So you see that it's all over. We have gold all over. And we have the small scale miners scattered all over the country. Okay, now the small scale mining. Let's start from the positive side. It contributes significantly to gold production. And in fact, most of the gold that is left in the country comes from the small scale mining arena. Because the large scale, because they are multinational, usually the gold produced is exported. So if I need gold for my ring, it is most likely gold coming from the small scale mining companies. In Ghana today, it's estimated that it employs about 1.5 million. That is direct employment. And then if we scale it up, that is the auxiliary employment that it creates around. People selling over there, people, depending on these miners and all that, is estimated at 6 million. So when there's a small-scale mine within a vicinity, it's able to create jobs for the people there, and it will reduce the rate at which people from that vicinity would want to move into the urban areas. So it boosts the local economy. Right. Let's look at the way the processing goes. Yes. So yes, it's bringing something positive. But why are we in this issue? I don't want to say mess, but otherwise, to put it bluntly, I'll say, why are we in the mess? Let's look at what happens here. We look at the small scale. Look at this picture. We have all these are human beings. What are they doing? They are moving the ore from one person to the other. If you look at this one, they have the ore packed into sacks, so that they can carry the ore to the processing site. So whereas the large scale will use these big trucks to move the ore, or conveyor belts to move the ore, in this case, human beings would have to do that work, especially in the illegal mining processing. See this one? This one is in the northern area, where water is an issue. Indeed, gold processing requires huge volumes of water. So where they don't have water, they do what is called winnowing. So they have to break the particles like this. It's not so hard anyway. And then, see this man, what he's doing. So it is also depending on the same gravity. Because gold is heavy, as they pour it from the top, see, the lighter ones will move away, and the ones containing gold will move quite straight into the pan. So that is what they do as the primary concentration. And when they have a smaller amount and concentrated amount, then they can use gold pan to pan it. Okay. Let's look at usually the central and southern areas. What happens is that we may have very hard rocks, and those hard rocks will have to undergo comminution or size reduction. And so we have various comminution machines used by the small-scale miners. Indeed, this is a ball mill. And now we have some small-scale miners or mining sites that are quite well organized, and they have moved on to have ball mills, which will have an enclosed structure like we have here, instead of just milling the material and the dust moving into the environment. The ball mill will work with water, so it does not allow the dust to go out. All right. Then once we have the material in smaller pieces, that's fine particles, this is what goes on. And this is actually a concentration process. It's concentration process. Okay? It is also using the fact that gold is heavier, gravity concentration. So what happens is that we have the board slanted, and then they put refills, material that has refills, pockets in it. So when they wash the material on it, the lighter ones will move out, and the heavier ones will be trapped in the blanket. And that is how they get the gold concentrated. And because of the way it is, it requires a lot of people to be around it to work. That is why we have all these are human beings running around it. If you look at this is actually the alluvial type or the placer type. So they fetch the material, it's already the gold is already liberated. So they wash it right there. And since they are using a lot of water, then you see the water around in that mess. This one, you see that they have moved it to a different site where they are doing the processing. And once they have the primary concentrate, like what we have here, this is gold, they have to reconcentrate it in a gold pan. So they are doing primary concentration and secondary concentration, which is taught in the universities to minerals engineers. Okay, so they do it like that, and once they have the final concentrate, the next thing is to bring in the mercury, and that is amalgamation, which is also taught in the university. So they add the mercury to the concentrate, and you see the way they are doing it. So all these things are indeed processes that are used in the minerals industry, but it is the approach which is wrong and which is bringing the mess that we find ourselves in. So somebody is using the hand. Meanwhile, mercury is poisonous. See? And the other thing is that when they finish, then that water, once the gold is taken out, see that they are not so much interested in the rest because it is waste, especially, again, the illegal ones. They are in a hurry. The galamsey is actually coming from gather them and sell. So they want to quickly gather and go and sell. So once they get what they want, they are not going to care about the waste that is produced. And that is the reason why we have the mess that we are all dealing with. Look at this one. So once the gold comes into contact with the mercury, the product that is formed is called amalgam. That is amalgam. So this amalgam will have to come into contact with water. Heat, fire, heat. And the heat will cause the mercury to evaporate so that the gold will be obtained. Now, this process is actually called retorting, where the heat will cause the mercury to evaporate. And they do it like this, see, in the open fire. So that mercury, gaseous form of mercury coming out, where will it go? Into the atmosphere. Okay. But once they do that, then they have the sponge gold, which they will now smelt with some chemicals and get the gold like this, so that they will go and sell. They gather and they sell. Okay. Let's look at some interventions before I bring my lecture to a close. For the small-scale mining in particular, there are some devices that can help, see, and they are already available. So it is the willpower, the ability to use it. This is the gold capture. So that is the gold capture. Then we have a retort. All these are mercury-free processes. They are supposed to be used by the small-scale miners so that they do not bring in mercury. Okay. So if they use this retort, for example, what is happening is that that part will go to the heat source, so the mercury will heat up. It will turn into a gas, just as what they are doing. But in this case, it is going to pass through the tube and go through condensation. I believe my students, you know that, right? So the gas will become what? Okay, so it will come back as liquid, okay? And that mercury can be reused. So if they do it like that, they are saving cost and they are saving the environment as well. All right. And this is called the portable smelter that we call locally as sikabuchia. So this sikabuchia, what it does is that once we go through the concentration and we get the gold concentrate from the sluice board, from the gold pan, no mercury, we just put it in this container with the necessary chemicals. We smelt and we get the gold bar at the small scale level. Right. So, the environmental issues. Now, having talked about everything I've talked about, you realize that the ore that we are dealing with is a fixed resource. Fixed resource. So, assuming, let's say, 300 years ago, 1,000 years ago, people went to the river banks. They saw the alluvial type of ore, very big. So maybe at that time, you could go and you see this. When you pick it, and at that time, the population was very small. At that time, I don't think they wanted a whole lot of things like the way we want everything today. So maybe if I go and I pick this, I'm okay. I wouldn't go again. And it is big enough. I pick it with my hand. So I don't have to go through all these processes. Maybe after some 100, 500 years, when you go, this one will not be there. It will not be there. So maybe by that time, when I go, it will be smaller pieces. When I pick one, it is not enough. So I have to go around and pick a number of them and put together. Then on and on and on, that one will not be available. So now we are in a situation where the high-grade ores are all gone. We are dealing with low-grade ores. We are dealing with very tiny gold particles. We are also dealing with high population. Everybody competing for the same resource. So for somebody to be able to get enough for the money invested, it means the person has to move huge volumes of the material. And once we do that, then we are hurting the earth. If we do it and we are able to return the material back into the earth, and we are able to treat the material, remove the chemicals, and if we removed trees and plants, we have to do reforestation. I believe that before this space was built, there were some trees here. So we clear the trees, and then we do something here for civilization. We want to have all the beautiful cars. We want to have all the new mobile phones and all that. All these are coming from the earth. So as long as we continue to over-depend on the resources, it means that we need to go there and bring them. But can we do it sustainably? And the answer is yes. But it takes some commitment to be able to mine sustainably. And then, in quotes, if you allow me, renovate where we picked the material from. If you go to some large mining companies, large scale, they show you some places that they did reforestation. You realize that it contains different kinds of species. And it is looking so nice. Some of them are able to replant palm trees in old tailings dams. Because for the large scale, before they will even start, there's something they call reclamation bond. They have to post it. That means they have to put a huge amount of money down for decommissioning. So before they leave the site, if they have not done that, then that money is going to be lost, to be taken to renovate the space. So I believe that if we are able to enforce some of these things in the small-scale mining arena, then we will be able to make a headway. We talk about mercury a lot. I mean, a whole lot about people, pregnant women with babies born, deformities and all that. Indeed, it is not only the mercury. if the area contains the complex ores, sulfidic ores, arsenic ores, what happens is that once they cut through and they leave water on the ground, the sulfide there will undergo oxidation. And when it undergoes oxidation, it's going to generate acid, sulfuric acid. The sulfuric acid is able to dissolve heavy metals. So if we have lead over there, it will dissolve. If we have zinc, if we have copper, if we have all those heavy metals, will dissolve. And once they dissolve, they are in liquid, they are in motion, so they will move. And if there's a water body somewhere, they will move into it, contaminate it, and then what happens? When human beings drink, then they have a problem. Because even though I initially said the health industry uses some of these elements or metals, they are in trace quantities. Once it goes beyond a certain threshold, if you take it, you have a problem. So I think that it's a call to action that we all must come on board. All hands should be on deck. And we should look at lasting solution. You go to these small-scale sites or galamsey sites, they leave pits over there. They leave those pits over there. I mean, it can cause accident and all that. The recommendation is that they have to use what we call 3-pond system. And that will be a replica of the tailings dam that the large-scale mining companies are using, so that even the water in there can be reused. Because the large-scale miners, the amount of water they use, if they have to throw it away and always get fresh water, the process will be too expensive. So if the small-scale miners are able to manage the tailings, that is the waste, and then move the water back for reuse, stop using the mercury and use the mercury-free processes, I believe that it will be good for all of us. So education, education, education. Education on cleaner processes. Universities, regulatory agencies, research institutions, we all need to educate. CSOs, chief opinion leaders, in fact, all stakeholders, students, you also have your share. You also must educate. You need to read a lot and get the understanding so that when you are educating, you also do it in the right way. So I believe that I have been able to give you a bit, just a bit, about how gold is obtained from the earth crust, the processes that we take it through. And because we are taking 1 out of 1,000,000, what we are returning back into the earth is the 1 million that we took. But in which form is it going? It is no more the rock that was together. It becomes fine sand mixed with water, sometimes mixed with chemicals that we are taking back. If we don't put in the necessary measures to curtail any form of environmental degradation, then it is going to affect the whole nation. And indeed, it will not be a good story for all of us. Thank you very much for your attention.
I think our speaker needs another round of applause. She has dealt wonderfully with her subject, and I think we're all better for it. I won't attempt to summarize, but a few take-home messages that I got. She's even summarized for us, elegantly. But basically, I now understand, just mining. There's some intelligent understanding to it now. And the interesting thing is that the whole country, maybe that's why everyone is going into mining, because the whole country is, full of gold. So if it's not regulated, I think everyone will feel like going to get a piece of the gold. And in this case, then we'll all be killing ourselves. We got educated Mineralogy 101, or as I can call it, or Metallurgy 101, and mineral beneficiation. Now, that word is quite new, and I need to do a bit more research to understand it. But this is what it's all about, mineral beneficiation, to understand what is going on. There's separation. This is the separation of what is good in the product you're using and putting back what you don't need. So if we can understand that mining is what you need is very tiny, 1 in a million, which means that if we're not careful, we're going to excavate the whole land for just 1 million. And if we don't regulate and get everyone going out there to just get 1 of a millionth, then we're just going to kill ourselves. The separation, and then we are educated into, and she just tells us a number of things that are also mined. Mining is a process. Mining for salt, mining for construction. So we're living because of our life demands. We need mining, but we need to do it sustainably. And then she tells us the impact of this mining, because when you're mining, the effects on the health. You're mining for gold, you're mining for magnesium, titanium, and if you're not doing it right, the products of it, gaseous in water, all impact on the health. And then, and we mine, our roads, you need bitumen, you need a coal tar. So our lives are very dependent on mining. But we've got to do it regulated, or else we'll destroy our nation. And then she even says, we're talking about renewable energy. But even that, for electric cars, you need the steel for the structure. So even then, you're going to need to mine for that, ore. And then the steel, you're going to, even if it's zero contamination, you still need a cobalt for all those parts. So then how do you mine them from the earth? And then she's taking us through the process of large-scale mining. And you can see that when mining is regulated, there's sanity and there are checks and balances. But the sad thing is that when they do that, all the gold ends up being exported. So we really come back to the small-scale miners, who apparently all the gold that we want to use ourselves are from the small-scale miners. So if we don't take time to educate the small-scale miners, so that, so long as they know there is gold, they will mine. So the point is that I think there should be, it's become insane, because they see that, and it's the tailings actually. Apparently, we're born in the wrong time. The older people would just go to alluvial and just pick up these gold stones. But we're looking for tiny bits of stone in this sand. So we've got to educate, and put some structures in place. I think there should be a moratorium, a halt. Let's find out who, so the large-scale mining are doing things right. The small-scale are not doing things right. There needs to education. We need to bring all stakeholders on board. I think today's lecture has been an education for all of us. How mining should be done, and how, when regulated, I think it would be good for all of us. So, without much ado, and speaker has. Okay. Oh, yeah. Oh, okay. Well, I am being, requested that because this is really such a topical niche. I mean, that's all we've been talking about all week and, the past months. So I feel that a few questions, are you ready for it? Yes, she's up to it. So I think we'll open the floor for a few questions and answers, which will even be clarify things a bit better for us. You're being put on the spot, but I'm sure you rise to the occasion. Thank you. So you get up, you say your name, where you're coming from, and short. Don't give a lecture. Just short questions. Thank you. There's only one.
Prof. Chair, thank you. Please, I'm Israel Mensa from Presec Legon, second year. Prof. Chair, I want to ask if there are mercury-free technologies we could use to mine minerals. I'm asking, why can't the government get those mercury-free technologies and then give them to the small-scale or artisan miners so that they could later pay on a reduced price, which will serve as an incentive for them in their area of work? And then again, I want to ask, why is it so difficult for the government in fighting this artisan small-scale miners? Because we've been talking about, I've been hearing galamsey since, and then I'm asking, why is it so difficult for the government in fighting this galamsey problem? Is it because of commitment, or they are no capital, or access to resources, or whatever? And again, what is the government doing in fighting this small-scale miners?
Okay. Two questions came. Why the government cannot give some incentives, right, regarding the mercury-free processes? And also, why is it difficult for the government to fight galamsey? Okay. Unfortunately, I will say I'm not representing government here. Yes. So let's get that first. So if the questions are to government, then probably I'm not the right person to answer it. But I will attempt from my technical point of view. I know that Minerals Commission came up with gold catcher. Okay. Let me talk about what I even know from my background as a lecturer. And can I have the permission to recognize my Vice Chancellor here, Professor Richard Amankwa? Prof. I believe that he will help me because he is an expert in this area more than myself. So I believe that he can also help. I know that even from our side, we have done a lot in trying to educate these miners. In fact, UMAT runs a school on small-scale mining. We had our conference just in August, and we had about 3 days or to 1 week just to train people on doing it right. And it is something we do a lot. UMAT came up with this sikabuchia that I showed. Okay? We have trained some miners on how to use it. We have do demonstration in the mining areas, small-scale mine site. We also have a lantern retort which is able to recover the mercury for reuse. So you see, sometimes I don't want to sound, I don't want to be drawn into government or politics because I am not. Yeah, but if I look at our small area, to what extent do we abide by laws? You see? So as I'm saying, from our side as educators, we have tried to educate these miners to do it right. We keep bringing them to the university to train them. We go to the site to, do demonstration on these equipment. But for the person to use it, I think that decision is for that person. And I believe it's just the average Ghanaian being lawless, in quote. And that is what brings about some of these things. So maybe this is what I can say about your question. Thank you.
All right, thank you very much. Please, let's take 2 more questions and then we can bring this session to a close.
By the name Daniel Ajiman from the Accra Academy. So during your lecture, you stated that at some point when the waste storage areas of these large-scale mining industries become full, they halt the activities. So with this, is it that the industry completely shuts down? Or if no, then how then do they deal with these waste? And moreover, you stated that the small-scale mining industry provides employment to about 1.5 million people directly and 6 million people indirectly. So in the battle of this galamsey, how then does the government find a job or a means of employment for these great number of people?
Yes. Let's take the last question.
My name is Lawrence Mante, and then my question is very simple. Please, can you pick a gold in its pure form without it going through the processing? Thank you.
Okay, thank you. Okay, so if the tailings dam is full, I said that if that mining company would have to halt its activity. So, if you were the mining company, would you wait for it to be full? You will not wait. So they don't wait. They don't wait for it to be full. Okay. So all these are seriously regulated, as I said. They have experts taking care of the tailings dam, just the waste. They have a whole department, environment, people paid just to make sure that the processing people, like us, I'm a processing engineer, are not polluting the environment with their processes. The same mine, but the environmental people, they act as policemen on the processing people. And that is the way it goes. The safety people are always on the ground. If you don't wear your PPEs, personal protective equipment, they are on you. And the mining companies, they actually have competitions, safety competitions. And if your mine wins, it's a big plus for you globally. So they take it very, very seriously. Now, if the tailings dam becomes full and the mining company doesn't do anything, it's not even the mining company that was shut down. The regulators will shut down and, slap a huge fine on the mining company. That is the way it goes. So if they check and it's getting full, they themselves will have to create another one or expand it, and that's the way it goes. If you look at the huge amount of material being processed in a day, it's a continuous process. If you shut it down, you have a huge problem. The material will settle in the equipment, and by the time you go back after 1 week, it's a huge mess. you cannot contain it. If you shut down a large-scale mining company for 2 days, the problem that we will have in this country, it will not be easy to contain. So that is the way it is. There was another question about government finding jobs. Once again, I cannot answer that directly, but what I know is that people have talked about alternative livelihood projects. Government, non-governmental agencies, they have trained people in the community about alternative livelihood programs. But you know, somebody who is into galamsey goes there, if he's lucky, gets it within a day. You teach him how to plant maybe cassava, or how to rear, what's the name of this animal? Grass cutter. It will take a long time. So that is the problems that come up. Yeah. And people believe that, again, education, George, or let's reason together and see what works best. So that is now, can you go and find gold and pick it? In the olden days, it was very, very possible. In fact, even when I was in school in the 90s, we visited one mine, and the gold particles were like this. I mean, you could touch them, you could hold them. And it was an alluvial mining from riverbank. Yeah, those ones are naturally liberated. You pick them, you know, you do concentration and you get them. But like I said earlier on, once we take those ones, if you go there today, they are no more there. So those ones are gone forever because it is a fixed resource. It is not renewable. But I know that even in the large scale, once in a while, they can hit a vein. That one, when they hit it, they don't mine it and dilute it. They will have to use a hammer, you know, to just break it and take it straight to the mining manager. Okay.
All right, thank you very much. Our lecturer, and I'm sure you all agree with me that this has been a very educative lecture on mining processes and mineral resource management. Just some few announcements and then we'll be out of here. So we have upcoming lectures. The first one will be delivered, this is an inaugural lecture, will be delivered by Professor Samuel Ajay-Mensah, a fellow of the Academy, on the topic Flavors of Spatial Diversity in Drinking Water Access in Ghana. And this will be delivered on Thursday, 17th October 2024 in this very auditorium. And the time is 5:30 p.m. The next will also be an inaugural lecture to be delivered by Professor Regina Appiah-Oppong, a fellow of the Academy, and the topic is on medicinal plants, a rich natural resource of Ghana to be harnessed for national development. And this will be held on Thursday, 31st October 2024 in this auditorium, Kwame Nkrumah Auditorium at 5:30 p.m. And then we'll have Founders Week celebration on the theme Leveraging the Fourth Industrial Revolution. And this event will take place from Tuesday, 12th November to Friday, 15th November 2024 in this auditorium, Kwame Nkrumah Auditorium at 5:30 p.m. Ladies and gentlemen, let me recognize fellows who were able to attend this lecture. We have all of them sitting right here, and some who were able to join online. I want to thank all of you for making the time. But let me specifically recognize our president, Professor Kofi Nti, sitting right here. And Prof. Intin was my dean at the University of Ghana Business School. In fact, he recruited me to the business school. And then we have two of our former vice chancellors. We have Emeritus Professor Ivan Adai-Mensah. Thank you, Prof. Then we have our former VC, Emeritus Professor CMB Tego. Prof, you're welcome. Let's recognize two schools who were able to attend the lecture. Presec High School. Please give us a wave. Good. Thank you for coming. And then Accra Academy High School. Okay, great. Accra Kableo. All right, ladies and gentlemen, we have refreshment right after. We have refreshment right after the lecture, so don't be in a hurry to go. We want to especially recognize the family of our lecturer, Professor Ofori-Sarpong, the family of Prof. Please give us a wave. Thank you for coming to give her the moral support and to grace the occasion. Thank you very much for coming. Thank you, and thank you to everybody. Yes, Rabotech, we want to recognize you again. We did that at the very beginning, but we thank you for your sponsorship. Are they here? Okay, thank you very much. Thank you for your support. And we trust that you keep supporting the academy. God bless you. Thank you very much, and have a good evening, all of you. Please, if you can be on your feet so that the high table.